Hello students, welcome to Saurav Sir's classes. Today we would be learning about the negative binomial distribution. Now the negative binomial distribution, this is a logical extension of the geometric distribution. Here the random variable x denotes the number of independent and identical Bernoulli trials required to obtain exactly our successes, where r is an integer. Now over here the last outcome must be a success, that is, the rth success, and the rest r minus 1 successes must occur in previous x minus 1 repetitions or trials before the last outcome, which is always a success. Hence, the PMF of x is given by, let me do it with a different color. So probability x is equal to x minus 1 CR minus 1 p to the power r minus 1 into 1 minus p x minus 1 bar minus r minus 1 bar into p, where x ranges from r plus 1 and so on, and this PMF can be further simplified to and written as x minus 1 CR minus 1 p to the power r 1 minus p to the power x minus r, where p represents the probability of success for each trial. Now, looking at the mean and variance, so mean, which is mu is equal to expectation x, is given by r by p, whereas variance, that is sigma square, is equal to Vx, is given by r into 1 minus p by p square. Now q is equal to 1 minus p, so variance becomes rq by p square. Here we may note that a negative binomial random variable with r successes can be viewed as the sum of r independent geometric random variables, each giving one success, and the moment generating function, that is the MGF, for a negative binomial distribution is given as p e to the power t by 1 minus q e to the power t whole to the power r. Thank you for watching this video and stay tuned for further videos on statistical concepts from Saurav sir's classes.